We're going to do a very quick example of just how to graph a quadratic. And this is just going to be a one-page quick example. So it's just an extra example. For the full lecture, just see chapter 3.3. So it says, consider the quadratic function. And we have your function here where A is equal to 3, B is equal to 6, and C is equal to -1. And we are trying to sketch this graph. So the first thing we want to do is make sure we have a visual picture of what our graph is going to look like. Now that is going to come from your A. So A being 3, since it is positive, so greater than 0, we're going to be concave up. So going upward facing. So at the end of our graphing video, we should have a graph that is a U-shaped going upward. Now your next thing that we want to do, we want to make sure that we find your axis of symmetry. So that has the equation -b over 2a, or x is equal to -b over 2a, because axis of symmetry is a line. So we're going to be taking b here, and we're going to be dividing it by 2 over a. So you have it's equal to -b, so -6 over 2 times a, which is 3. So we have -6 over 6, or x is equal to -1. So while x is equal to -1, on your graph, we have this axis of symmetry right here. So now that you have your axis of symmetry, we get to take this particular x and we get to then plug it into your equation. So we have f of -1 is equal to 3. And we're just going to replace your x values from your equation up above, and we get to plug it in. Now, the reason why we do that is because your axis of symmetry has this equation, which the axis of symmetry, we're trying to find your vertex, and it has the same relationship with your vertex. It's going to be the x value of your vertex. You'll see here that with your vertex, we get to plug in your x value to find the y coordinate. We get to plug it in. We have, let's see, 3 minus 6 minus 1. Or let's see, that's 3 minus -7 to be a -4. So we're looking at the coordinate -1, -4. Let's go ahead and put that on your graph here. -1, -4, 1, 2, 3, 4. Right there. So that is your point -1, -4. And keep in mind your graph is going to be upward facing. So this is the lowest point of your graph. That's the minimum value. You notice that this says maximum. It most likely used to be a maximum, but anytime we have that upward facing graph, we're looking at a valley here. So this is going to be a minimum when y is -4. It's your smallest y value. You could also put the y or x and y coordinate together to tell us the location of it. Or if it's just asking for a value like we are here, it's just whatever your y value happens to be. So let's figure out some other points to graph. So number 4, we're going to be looking at your intercepts. So let's take a look at your y-intercept. This is any time we set x equal to 0. So we can go ahead and put 0 in. 3 squared plus 6, 0, -1. So you'll notice that it's -1. Now this comes into play because this is called your constant. So in this form, your constant is acting as your y-intercept. So we have your y-intercept here at 0, -1. So we are 0, -1 right here. Now with your axis of symmetry, this something to be symmetrical is that what happens on one side of the graph happens on the other side at the equal degree. So if we take this axis of symmetry, which is just your x value, and if we went 1 to the right-hand side, we then get to go 1 to the left of your graph. So by putting in this extra point, we now have 3 points. And this is a point 0, -1. And your other point here is -2, -1. It should share the same y coordinate as you do on the other side. Because again, to be symmetrical, what happens on one side also happens on the other. It's like a mirror. So think about this line as being a mirror. Now, most likely you're going to be asked to find 5 points in total. Now, you can, if you wish, to find your x-intercept to see if they are factorable, if they come out nice and clean. So if we can try, let's see if we want to try and factor this. This is when we have y equals to 0. So we have 3x squared plus 6x minus 1. In order to factor this, or to see if it is factorable at all, because we're trying to look for where your graph meets the x-axis. And we definitely want to we definitely want to plot nicer points for us. So if it comes out to be not factorable, which in our case, most likely it won't, because we're looking at factors of 3, 1, and 3, that can get us to a +6, which there's no way that we can get 1 and 3 to be a +6. So while it's not factorable, we could go ahead and solve this using the quadratic formula, but do we really want to plot some messy points if they're not coming out? No. So it just means that most likely we're going to just have some really messy x-intercept points. So we won't have to go ahead and plot those. So instead, we can find additional points. We can do this by just making a table. So we can pick x values, which we typically want to surround your vertex. So if we have the x value of -1 around your vertex and your y value is -4, then on either side of this one, we want to make sure we plot those first. So we notice that you have 0 and -2 already on either side. So you have -2, you have 0 already plotted, -1, -1. So now let's plot another point. So branching out now to perhaps the next nice points, we can do 1 and -3. Now it doesn't matter which one you choose. You can do both if you would like, but all we're going to do is practice plotting, plugging these points in to your equation that you're seeing here. So let's plot 1 into your graph. So we get 3 plus 6 minus 1, so that's 9. Minus 1 is 8. So we put in a 1, we get out an 8, and that just means that will go the same for if we plug in a 3. So let's see if we plot that point. So at 1, we're all the way up at 8. 1, 2, 3, 4, 5, 6, 7. You're a little off your graph here. Let's see, 1, 8. And that's -3. Then you can go ahead and plot your points or connect the dots. And there you go. That is our graph. Now, when it comes to graphing, your standard vertex form, so part A, we're going to need 3 things. 1 is the A itself, 2 being the vertex, and 3 being your vertex form. Your vertex form being A, x minus h squared minus k. And actually, let me take that and bring that down just a little bit. And we're going to go ahead and start to replace what we already have. So we have A being 3. We have -1 acting as your h here. And we have -4 acting as your k. And I'm so sorry, I wrote the equation wrong. It should be plus k. So we can go ahead and work this in. So a we said is 3, x minus a -1 squared plus a -4, which is your k. So cleaning that up, we have 3x plus 1 squared minus 4. So this should be our final answer when it comes to your vertex form. And that is how we can graph a really quick graph. Again, if you had your x-intercepts here, if they came out really nicely, we could go ahead and factor it. But since they don't, we don't have to put those on the graph unless it is asking specifically. Some of your graphs might only have one x-intercept, some are going to have 2, and others might not have any depending on the concavity and where it is in your coordinates.